Heidi ho, geometries. Today, I'm not planning to hold it like it's cold or even lukewarm. We are going to drop it like it's hot on Unit 7, Day 7. Now, hopefully you dominated the quiz because you practiced it. I do want to show you the Day 8 homework because we have two proofs on the test. From the notes, this homework, and the review, you will have seen the exact proofs or something very similar to that. So I'm going to start with that, and then I'm going to go over the Day 7 notes. We just have one more uh, rule to add that you probably could have figured out on your own and done a different way, but it's a bit of a shortcut. So this is a little bit hard to see. Um, there are two different versions of this on the, hold on a second, I have a visitor. Okay, so the first one is looking at these two triangles. And in these two triangles, you have the reflexive property. Since it is perpendicular, you can say angles 1 and angle 2 are right angles, then all right angles are congruent. And if a diameter is perpendicular to a chord, it bisects it into two equal pieces. So we had side angle side to prove they were congruent, and then CPCTC. The other has to do with talking about arcs. So you can read that. That's less likely to show up. Normally, we're going to see a proof that has triangles are congruent or triangles are similar. So here is our second problem. Okay, again, you're looking for PLN to be similar to PMN. All right, so right here, this angle is reflexive. It's in both triangles. And then we have to have a step for this is a right angle because it's opening up to the diameter. So TEF 180. This is a right angle because a tangent and a radius or a diameter form a right angle. Then all right angles are congruent. We use angle-angle similarity. Okay, on the back, you could have done this a couple ways. They want you to do transformations. The easiest thing to do is you like translate one to the other. So this one says translate circle A, so A maps onto B. So then it would be right here. And then if you wanted to make it smaller, you would do a scale factor of 1.5 over 4 to circle A. Make sure you have it like where is it centered? It's centered at point A. If you did the other one, you would have flipped it. So circle B about point B, you would have done a scale factor of 4 over 1.5. Definitely something that's going to show up on our test. Okay, and then this one, again, like this cues me that it's congruence. I used these two triangles. So in them, I had the reflexive property, all radii are the same, all tangents are the same. You could have gone with the right angles and then done side angle side or hypotenuse leg. But my final step of this should have been CPCTC. So I'm hoping you had something of this. You're getting at least a point or two out of this, and then you can watch this part of the video again to make that happen. So we are going to turn in our notes. We're going to go backwards to page 47. Pause the video, get there. And some of this stuff we've talked about before, okay? If we're going to put a circle around a polygon, it's called circumscribed. We did this before with centers of concurrency. The three perpendicular bisectors find the circumcenter. And then the other option is if we put the circle inside of the shape, we would then, an inscribed circle is tangent to all the sides. So this is only hitting once in each spot. And for us, we see this a lot. Like those two tangents are the same. These two tangents are the same. And these two tangents are the same. So we've done that problem a few times. Okay, so I don't think this is on here, but just as a review, the center of this circle is called the circumcenter. This is the concurrency of the three perpendicular bisectors. We did that in unit 5.5. The center of this circle is called the incenter. Get it? Inscribed, incenter. And this is the concurrency of, that's not moving, the three angle bisectors. The other thing we did in Unit 5.5 was the three medians found the centroid, and the special piece of that was it broke each median into a 2-to-1 ratio. Okay, so today we're going to kind of do a shortcut. This is called a cyclic quadrilateral, and the vertices are on the circle. Like we've tried to solve this before, and it's a little bit more intense. Okay, so that's it right there. All right, and I could go through, you know, a bunch of pieces of this. Something to kind of understand is all of these have to be the same because it's a radius. Okay, so if I called this angle 1 and that angle 1, they had to be the same because it's isosceles. This would be 2 and 2, this would be 3 and 3, this would be 4 and 4. And we know that all of them added up should equal 360. And then we can figure out pairs-wise that this pair and that pair should add to 180, and then this pair and that pair should add to 180. Okay, so the main goal of this, and I could go through this if you were really wondering, if it's a cyclic quadrilateral, the opposite angles add to 180. Okay, it has to deal with how much of the circle we're dealing with. All right, so another explanation, I guess, would be that this is inscribed and would be half of that. This is inscribed and would be half of that. Together, it's the whole circle. Half of the whole circle is 180 degrees. So some of the questions are easier if they're straightforward. Some of them are a little bit more difficult. Feel free to pause the video at any time. But once I figure out, all right, this is inscribed in the circle. These angles are across from each other. They have to add to 180. So if I subtracted 75 from both sides, I'd learn that angle X is 105. Okay, but the Regents exam likes to make it more tricky. So if they're going to put more things in the picture, all right, I have to realize that right now, this shape, if I follow the outside, is really a pentagon. Okay, so if I can identify that right here is a triangle, then I can figure out what this angle is by subtracting those away from 180. And then if I recognize over here, this is my cyclic quadrilateral because all four corners are there. And this little angle and the 135 are across from each other. So I would subtract 135 from 180. And then angle X once them together. So put them together and what do you get? 45 plus 51 equals 96. I don't know my video, my my rap album if I should use auto tune or not for that, but just leave a comment in the comment bin for me to read over. Hopefully the mic quality is a little bit better. Okay, so I'm going to go over 3, 4, 5, and 7. And then I want to talk a little bit about if I had parallel chords inside of a circle. Okay, I'd like it if you pause the video and tried 3, 4, 5, and 7, and then press play again. But we all know, kind of what happens. So if you're going to pause the video, now would be the time for that. And if not, we'll just kind of get right into it. So if I'm looking at this, I see some triangles, but I don't have enough angles to add to 180. Okay, so I see some shapes and I figured out that, all right, right here is a cyclic quadrilateral and those two are across from each other. And then right here is another cyclic quadrilateral and those two are across from each other. So I started off with Y. I subtracted 180 minus 58. So now I know that Y equals 22 degrees. And then I went with the blue and I subtracted 22 from that. And whether you're feeling awkward or not, I was just making sure you paid attention there. If I subtract 122, I would again get 58 degrees. Okay, and hopefully that makes sense. On our proof day, we talked about inscribed angles that open up to the same arc. Both of these open up to that arc right there. So both of them have to be the same measure. So I could have just said they were 58 right from the start, but the cyclic part helped me with the value for Y. Okay, so the cyclic part is right here. So if this angle is 90, that angle has to be 90 because they're across from each other to add to 180. That makes this a whopping 52. And how does that help me? That helps me because those are radii. That makes this triangle isosceles. The base angles are congruent. And then I can figure out that angle X is the same as 180 minus 52 minus 52. And that leaves me with a grand total of X being 76 degrees. All right. If you did this with, trying to do inscribed angles, trying to figure the outside of the circle, that's another viable way. But anytime I know I have 4 corners inside of a shape, I can do this process. Okay. So 5 is a little bit more intense. I went through and I tried to determine if I had anything that was cyclic. And the only thing I do is here, 2, 3, 4, back to here. All right. So these two have to add to 180. So once I figured out that this was 40, now I have to kind of start to reinvestigate a few things. Okay, I don't have any more cyclic things. I don't have enough inside of a triangle to figure that out, if you remember that the four angles of a quadrilateral should add to 360, then we can get here, but this quadrilateral is not cyclic, okay? So you could add these up to figure out what that is, but I'm missing two angles. So the next option I did was this 40 degrees right here is inscribed to that. So this has to be 80 degrees. This 64 degrees is inscribed to this. So this has to be 128. Um, Awkward pause. And then, oh, here it is. So if this is my diameter right here, okay, then this would have to be 100 to add to 180 with that, okay? And then Y is technically two chords with the 100 and the 128. So Y equals 100 plus 128 divided by 2. So this would be 228 divided by 2, which gives me Y equals 114. Okay, and now I can start kind of building out more from that. What I would have done is, if this is 114, then this has to be 66, and then 66x 140 and 73 add to 360. And end up with x equaling 81 degrees. Okay, that one's really hard. That was a challenge problem. For those of you that don't like challenges, I greatly apologize. I'm not really interested in doing a proof for this, so I'm just going to talk about it. If my parallelogram is cyclic, I know that opposite angles have to be equal. Okay, and if this was an x, this is an x, so they would have to add to 180 because it's cyclic. And if this was y and this was y, this would have to add to 180 if it's cyclic. So both x and y would equal 90, and if the four corners are 90, that makes it a rectangle. This is the last one that's pretty tricky. Um, I don't want to go too in depth with it, other than if I see these are parallel, I could like bring 49 over to here. And then I can start trying to build out from that and see, okay, this is cyclic right here. So this and that would have to add to 180, and I could kind of keep going around and around with that. But the only other thing that I really wanted to make sure I covered was on page 50. So I think of this as like if I was slicing a piece of fruit and I was slicing through it like in the same direction, my wedges would be the same. So my like the peel would be the same if this was an orange. And a couple things that I have to kind of look for is if they're parallel, if they had a line between them, I could do alternate interior angles. But if they're telling me that this is 84 and these are parallel, I know that arc AC and arc BD has to be the same. So if I call this X, those are both the same. If I recognize that I have a diameter right here, then I know that this whole thing has to add to 180. And with whether you're impressed with my algebra skills or not, all right? We're looking for all the same ideas that we've looked for before. We're just kind of adding new rules to this. Okay, so I hope this wasn't too painful. When you're done, please raise your hand and get the homework from my substitute. And in closing, we've now finished Unit 7. It probably didn't feel like you're in heaven. In between 10 and 12 is the number 11. But be remix, be remix number 2, be ready for review so you don't feel blue after you take the test. And if you sneeze, you go at you. Stock money out.